Okay, let's have a quick chat about how do we use trigonometry to calculate unknown angles. Now, last video we were looking at how we can work out sides, lengths of unknown angles, but we can also use trigonometry to find out the angles themselves. So let's have a look at this. Let's just say that I have the tan of some unknown angle will give me a number, 0.1405. Now that's okay. Well, how do we actually figure this out? Well, back in the day, people used things like this. This is a very fancy ruler called a slide rule. Now, a slide rule was used by engineers, people who made roads and build buildings and all that sort of stuff to determine angles. This little middle part here, I don't know if you can tell or not, underneath this little metal bridge, it would slide back and forward, and you would be able to use this little part here to measure the angles based on the degrees and all that sort of stuff. Once you were trained in it, really easy to use from what I heard, and quite quick too. Okay, you could also use this here, this table of information. Now I've only got the first 21 degrees shown, whole degrees by the way. So you could imagine this goes all the way to 90. It's quite a large table of information. So we could use this. Let's try this. We're looking for the tan of an angle that is equal to 0.1405. So I'm going to consider my tan column right here. And I'm going to go down and I'm going to find 0.1405. Ah, there it is. I found it. Let me just put a line underneath it. 0.1405. And when I look back over at how many degrees it is, there you go, it's 8 degrees. So I could say that that missing theta, the angle, was 8 degrees. Okay, fair enough. That seems pretty good. All right, let's try another one. That was easy. We'll try this one. Something's popping up. Sine of theta is equal to 0.2391. All right, let's go down our sine column just here, and we'll see if we can find 0.2391. We've got a problem here. It's somewhere between here. I don't know exactly. So what's my angle going to be? My angle will be what? 13 and a half? 14.2? I don't know. The actual table doesn't have that exact value for sine. And so I'm kind of in a bit of a lurch. Okay, so let's think about, well, if the table's not much help, what can we actually do? Now, as an aside here, as a little side bit that'll make sense eventually, I want you to remember that an index rule that we have, that if we've got 1 over a, it's really the same as saying a to the negative 1. Okay, that's really what when we use the when we use our index laws, that's what we've got. So let's just say a really simple number. If I've got 6, and I want to, just say that 6 is equal to x, right? And well, that's actually not a great story. Let's say I've got 6x, and it's equal to, I don't know, some number, doesn't matter. Let's just say I wanted to work out what x is. Well, what I would actually do is I would multiply, I would divide by 6, right? Now, when I'm dividing by 6 over here, and I divide by 6 over here, what I'm really doing is I am multiplying. Let me just shift this over a little bit. This 6x really is being multiplied by 1 over 6, right? That's really what's happening. So I could represent that, instead of saying multiplied by 1 over 6, what I could do is I could say I'm multiplying by 6 to the negative 1. And that will be the same as if I was dividing by 6. And you might think to yourself, well, that's just confusing. Why would I bother doing that? It's for this trigonometry, right? When we have our sine of an angle is equal to 0.2391, well, we actually want to get the unknown, which is the theta, by itself. So we have to get rid of this sine over here. So how do we do that? Well, we multiply both sides by sine to the -1. It really kind of is like dividing by sine on both sides, but we don't want to divide by sine on both sides because you can't actually do a number divided by sine on your calculator because that doesn't make any sense. It's got to be sine of something. So what we do is we don't do this bit, we actually multiply by sine to the -1. Okay, so, and again, let me repeat that if we've got 1 over sine, which is what we're dividing by sine means, it really means sine to the -1 based on our index laws, this index law. Okay, all right, so let's think about, well, what does this look like in practice? Let me get rid of all this other stuff that we don't actually need anymore so that we don't have all this confusing stuff. Okay, so we have got in our problem over here, the sine of theta is equal to 0.2391, and I'm going to multiply both sides by sine to the -1. Okay, so what will that look like? Well, when I rewrite it, it will look just like this. That theta is equal to sine to the -1 of 0.2391. So let's grab up our calculator because that's what the tool that we use. So we're going to do this. Now, how do you do negative sine? How do you do sine to the -1 on a calculator? So the shift button, and then you hit sine, and you'll see that on the screen that it actually has sine to the -1, which is just what we want. And then we're going to put in our number, 0.2391, close our brackets and hit our equal sign, and it was 13.8. Now, if we go back to our table real quickly, we said that it was in between here, and if you think about it, 13.8 is in between those two numbers, between 13 and 14. So we can say that we successfully found the value of theta, right? We found the value of that angle that gave us this number, this 0.2391. Okay, so what I've done is I've shown you that we can use our trig ratios to find an angle. So let's see what that looks like in practice, in an actual question. Okay. I'm going to make these go a bit quicker because we've done these a fair bit. Okay. I have got myself a question. Here it is here. There's my triangle. Nothing fancy about it. Doesn't even have any units of measurement on it. Doesn't matter. We can still solve this thing. We ask ourselves the same questions to start with though. What sides do I have in this particular triangle? What have I been given? Well, the angle's down here, which makes this one over here the opposite, and this one next to it the adjacent. We don't have any hypotenuse, so which of these is adjacent and the opposite? And we know that it is going to be tan. Okay, so tan of the angle is equal to the opposite over the adjacent. I'm going to substitute in the things that I have. I'm going to substitute in the fact that, well, it's still tan of theta, but it's equal to 35 over 20. Okay, now, is theta by itself? Well, no, it's not. I'm going to multiply both sides by tan to the -1, because that's the inverse of tan. That's how I get rid of tan. Okay, so I'm going to end up with a calculation that looks a lot like this one here. Okay, theta is equal to tan to the -1 multiplied by 35 over 20. So let's do that. So shift tan, and it will be 35 divided by 20, and then I'm going to go to the end and close my brackets, and it gives me an answer of 16.25, which I'm happy to call 16.26 degrees, of course. The angle theta, degrees. All right, so I've solved it. I found I had two sides of a triangle, and I found what the angle was of theta. Very good. All right, let's do another one so that you can see. Really make sure that you're on top of this. Okay, here's my little triangle. Again, what sides are we dealing with? What ratio do I need? Well, here I know I've got the hypotenuse, and I have the side that is next to the angle, so this will be the adjacent. So which one is the adjacent and the hypotenuse? It'll be this one here. So I'm looking at cos. Cos will be the rule that I use. So I'll write that down. Cos of theta is equal to the adjacent over the hypotenuse. I substitute in what I know. Cos of theta is equal to 4.5 over 7. I'm going to then multiply both sides by cos to the -1 to find the inverse value. And I will quickly do that on the calculator to show you. So shift cos, and it will be 4.5 over 7. Close my brackets, and I will get 49.995 degrees, which is what I have. Okay, so that's how you do it. That's how you find the angle based on two sides. Okay, so trigonometry is actually a very useful thing, a good tool to have.